Hello friends, today I will discuss the transformer necessity, definition, terms used, symbol of transformer, construction, characteristics of ideal transformer and principle of the transformer. Let me cover first what is the necessity of the transformer. In general, the power is generated at low voltage level. This power can be transmitted to the receiving end at low voltage level, but it requires large diameter conductor, which increases the capital cost of the power transmission. In order to reduce the capital cost of the power transmission, voltage level of the power is increased so that the current level of power is reduced. And for this purpose, we use what is called transformer. With this, the copper losses in the transmission can be reduced, capital cost on the conductor reduces, and also it improves the voltage regulation of the transformer. Then what is the definition of transformer? Transformer is a static device or a machine or electrical machine which is used for transferring electrical power from one electrical circuit to the another electrical circuit via magnetic circuit without change in supply frequency but change in voltage and current. Next, what are the terms used in this video? Number one is primary winding. Primary winding means the winding of the transformer which is connected to the AC supply is called the primary winding. Secondary winding means this is the winding of the transformer connected to the load or left open. Next, R1. R1 is nothing but primary winding resistance, which is normally negligible. Next, X1 is the primary winding leakage reactance. This is also normally negligible. R2, it is the secondary resistance, secondary winding resistance. X2 means it is secondary leakage reactance. R2 dash means it is the secondary winding resistance referred to primary. X2 dash is the secondary reactance referred to the primary winding. Next, primary voltage, this is also called applied voltage to the winding, is represented with Vp or V1. Next, secondary voltage, this is the voltage across the load or across the terminals of the secondary winding. Next, primary induced voltage. This is the induced voltage in the primary winding and represented by Ep or E1. Next, secondary induced voltage. This is normally represented with Es or E2, and this is the induced EMF in the secondary winding. Then primary current. This is the current flowing in the primary winding and its symbol is Ip or I1. Next, secondary current. This is the current flowing in the secondary winding represented by Is or I2. Next, primary turns. These are the primary winding number of turns represented by Np or N1. Next, secondary winding turns represented by Ns or N2. then the turns ratio is normally represented with the K, and this is also represented with A, and that is equal to N2 by N1. Similarly, the voltage ratio is also represented with the K, which is equal also represented with small a, that is equal to V2 by V1. Similarly, the induced EMF ratio is represented by with K, and it's also represented by small a, that is equal to E2 by E1. Similarly, current ratio is represented by K, and it is also represented by small a, that is equal to I1 by I2. This turns ratio can also be written as K is equal to A is equal to N2 by N1 is equal to V2 by V1 is equal to E2 by E1 is equal to I1 by I2. Here it can be observed that the voltages are directly proportional to the turns, whereas the current is inversely proportional to the voltages and inversely proportional to the corresponding number of turns. Next, symbol of the transformer is like this. The transformer will have the two windings for a single phase transformer, and there is a core connecting these two windings like this. These two lines are called the magnetic core, and whereas this is one winding, this is another winding. If the winding is connected to the supply, it is called primary winding. If the winding is not connected to the supply, then that is called secondary winding. Now let us see what is the construction of the transformer. The construction of transformer consists of totally three circuits. One is called electrical circuit, the other is called magnetic circuit, the third one is called the insulation circuit. Electrical circuit consists of two windings. One is called primary winding, the other is called secondary winding. And these windings are wound over the magnetic core, and the magnetic core is insulated with the help of insulating oil, and these windings are insulated from each other with the help of bakelite sheet or cloth or paper, and this magnetic core is normally silicon steel, and its lamination thickness is normally 0.35 mm to 0.5 mm. Electrical circuit consists of three parameters, that is called Ohm's law. V is equal to IR, and here resistance is the passive element. For an ideal electrical circuit, the resistance should be less or negligible, so that the copper losses are less. And coming to the magnetic core, here the reluctance is the major one, that is MMF is equal to reluctance into flux. If the reluctance is very less, then the core loss, that is eddy current loss and hysteresis loss, will be less. And coming to the ideal characteristics of the transformer, we can get these characteristics by looking at the construction of the transformer, that is electrical circuit and magnetic circuit. That is, resistance should be negligible and copper loss is negligible, reluctance is negligible, core loss is negligible. When these four conditions are satisfied, then automatically the efficiency of the transformer rises to 100%. Principle of operation of the transformer. Here, a single phase transformer is taken like this. Here this is the magnetic core, and this magnetic core laminations are insulated with the help of insulating oil, and on one leg of the magnetic core, one winding is wound like this. Similarly, on the other leg of the magnetic core, another winding is connected or wound like this. And this winding is insulated from the magnetic core with the help of the insulation paper. Similarly, here also. And this one winding will be connected to the AC supply, and let us say this winding is connected to the AC supply, and this winding is said to be primary winding. It becomes a closed circuit. Then this primary winding draws the primary current called I1 because of the supply voltage V1. Then this I1 creates a flux in the magnetic core, and this flux links both the primary winding and the secondary winding. This is called secondary winding, which is left open like this. As the flux is linking with the primary winding, there is a rate of change of flux linking with this coil. So there is a induced EMF in the primary winding, and that induced voltage is called E1 here. And the flux created by the primary winding, we call it as phi, and the voltage induced because of the alternating flux linking with the secondary coil is represented by E2 like this. And this E1 and E2 are produced because of the Faraday's law, and these voltages E1 E2 are in phase, but they oppose the supply voltage as per the Lenz's law. If the vector diagram is drawn for this condition, you get like this. This is the applied voltage called V1, and this voltage V1 creates the flux which lags the voltage by 90 degrees like this, and the current flowing through the primary winding under no load condition is called the magnetizing current, and this will be in phase with the flux like this. And because of this flux, as per the number of turns in the primary winding and secondary winding, the induced voltages developed are E1 and E2, and they are in phase with each other like this. But these voltages will oppose the applied voltage like this by 180 degrees like this. And we can write the induced voltage E1 in the primary winding as minus N1 d5 by dt, and the induced voltage in the secondary winding as minus N2 d5 by dt. So here the induced voltage is directly proportional to the product of the number of turns on primary winding and rate of change of flux linking with the primary winding. And this minus sign indicates the Lenz's law, which shows this opposes the applied voltage. So similarly, E2 is the induced voltage in the secondary winding and represented by minus N2 d5 by dt, and this N2 is the number of turns on the secondary winding, and d5 by dt is the rate of flux linking with the secondary coil. In brief, the principle of transformer can be said that it depends upon the Faraday's law of mutual inductance.